Channel. So in today's class, we want to study binary number system, number basis. The usual system of counting in our days is called decimal ordinary system. This system enables us to write small or large number by combining digits, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each digit has its own place value. Place value tells us the position of each number. That is, if you write 6, 9, 8, 0, each number, 6 has its own place value, 9 has its own place value, 8 has its own place value, and 0 has its own place value. So in order to understand number basis very well, we have to understand place value. That is the position of each digit. For example, if I write 5980, what is the place value of 0? What is the place value of 8? What is the place value of 9? And what is the place value of 5? From here, the place value of 0 is units. The place value of 8 is tens. And the place value of 9 is hundreds. Place value of 5 is thousands. So you need to understand all these things very well. And this is the whole number. So what of place value for decimal numbers? If I write 12.34, what is the place value of after decimal place, after decimal points? So after decimal points is tenth with th. And after that one is hundredth with th. Before decimal point is units, and after that one is tens. So all these things, they are very, very important for you to understand number basis. Now, another thing is that you need to understand the power of any number. Now, if I write 10 raised to the power of negative 1, it means 1 over 10. That is tenths. 10 raised to the power of negative 2 means 1 over 10 raised to the power of 2, and that is hundredths. 10 raised to the power of negative 3 is equal to 1 over 10 raised to the power of 3, and that is thousands. Generally, we can now say that any number raised to the power of another number will be 1 over a raised to that another number. So a raised to the power of negative n will be equal to 1 over a raised to the power of n. You know that we can write this one. If you pronounce this one, is 5,980. So we can write it like this. Okay, you put this one, unit tens, 100,000. So we can say this is 5,000 plus, this is unit, this is tens, this is 100, and this is thousands. So under this 100, 9 will be there, and it has 2 zeros, plus 8 will be 100 tens, and the remaining 0 will be under 0, under units. Then add everything together. It gives us 0895. That is 5,000. So this 5,000, everything, we can now write them in power form. So 5,000 can be written as 5 times 1,000. And 900 can be written as 9 times 100. And 80 can be written as 8 times 10. And 0 can be written as 0 times 1. So to write 1,000 in power form, 1,000 will be equal to 10 raised to the power of 3. And 100 will be 10 raised to the power of 2. And 10 is equal to 10 raised to the power of 1. And 10 raised to the power of 0 will be equal to 1. So any number that is raised to the power of 0 is equal to 1. 5 raised to the power of 0 is equal to 1. Any letter raised to the power of 0 is equal to 1. Even if it is 1 million, 1 million raised to the power of 0 is equal to 1. So you have to note that, so that any number raised to the power of 0 is equal to 1. It's very, very important for you to understand that one. So this 5,000 can now be written as 5 times 10 raised to the power of 3 plus 9 times 10 raised to the power of 2 plus 8 times 10 raised to the power of 1 plus 0 times 10 raised to the power of 0. So that is how to expand it. So we are almost there. We are in number basis now. Now, for decimal numbers, if we write 1.34, now, I told you that this one is units. This is tens. And immediately after decimal point is tenths, th. And this one is hundreds with th. Now, if you want to write it, this is the whole number, and here is decimal points. So now, this one is tens. That means that is 1 times 10 raised to the power of 1 plus 2 times 10 raised to the power of 0, because I told you that any number raised to the power of 0 is equal to 1, plus this one will now be equal to 3 times 10 raised to the power of -1 plus 4 times 10 raised to the power of -2. Now, let me explain 10 raised to the power of -1 and so on. So, any number raised to the power of negative number will be equal to 1 over, like 10 raised to the power of -1 will be 1 over 10 raised to the power of 1. And 10 raised to the power of -2 is equal to 1 over 10 raised to the power of 2. So generally, we can say that a raised to the power of -n is equal to 1 over a raised to the power of n. So you have to understand all these things very, very well. And 10 raised to the power of -2, 3 is equal to 1 over 10 raised to the power of 3, and so on and so forth. Writing any figure like this, 5, is the same thing as writing it as 5 base 10. But since it is in base 10, and I told you that it is our way of counting numbers, it's our way of writing number, so there's no need for us to put base 10 there again. So we can easily, so any number you see, be it 2, is in base 10. So any number is in base 10. So, but we do not need to put base 10 there when we are writing it. If you want to write natural numbers, that is counting numbers, you now be writing 1, 2, 1 base 10, 2 base 10, it won't be easy. So that is why you do not need to put base 10 there, but you have to know that all of these numbers are in base 10. So combination of digits as well. If you write 386, is already in base 10. 386 base 10. So, but you do not need to write 6. So it's better you leave it like this. But you have to know that it's already in base 10. So apart from base 10, we have other bases. We have base 2. This base 2 is called binary system. We have base 5. Base 8, base 3, base 7, and so on. So if you want to write any number in basis form, it's advisable not to write it like, if you want to write 10 base 7, it is advisable not to write it like this. don't write it like this. It is advisable for you to write it in word. 10 base 10, 7. So that 7, write it in word. So if you want to write 101 in base 2, it is advisable not to write it like this, but to write it like this, 101 base 2. So write that your 2 in word. 143 is in base 10 already. So you can write it in expansion form. So it now be equal to, just put like this. So 1 times 10 raised to the power of, count the figure after it, 1, 2. So power 2. You know, if you put this unit, tens, 100. So you know it's already in 100 position. So plus 4 times 10 raised to the power of 1 plus 3 times 10 raised to the power of 0. I've explained that one before. Also, if you have digits that is in another base, let's say base 5, 385 in base 5, you want to expand this, you can easily say this is 3. Remember, this is units, this is tens, this is hundreds. It will be 3 times 5 raised to the power of 2 plus 8 times 5 raised to the power of 1 plus 5 times 5 raised to the power of 0. And always remember that any number raised to the power of 0, power of 0 is equal to 1. 0, or you can just write 0 is equal to 1. So here 5 raised to the power of 0 is equal to 1. So any number raised to the power of 0 is equal to 1. So if you have base 2 also, you expand it and you use that base to multiply it. So if you have 101 in base 2 and you want to expand it, just write like this. So for you to know the power of your 2, from units you write 0, then followed by 2, followed by 1, followed by 2. You know that this one will be 1 times 2 raised to the power 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. So that is how to write them in expansion form. So similarly, if you have the number 1101.101, you know, this 0 means its position is units, and this one means its position is tens, and this one means its position is hundreds, and this 3 means its position is thousands. So after decimal points, which is tens, will be -1. That means that is tenths with th. This one is -2, and that is hundreds. And this one means -3, and that is thousands. So if you now want to write it in the expanded form, so this one will be, you know, it's in base 2, and I told you that if you want to expand it, you'll be multiplying each number by 2. So 1 times 2 raised to the power of 3 plus 1 times 2 raised to the power of 2 plus 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0 plus 1 times 2 raised to the power of -1 plus 0 times 2 raised to the power of -2 plus 1 times 2 raised to the power of negative 3. So you have to note all this one. If you see raised to the power of negative 1, you know it is tenths. If you see raised to the power of negative 2, you know it's in hundreds. If you see raised to the power of negative 3, you know it's in thousands. So that is that. Now, let's solve another example. Write the following numbers in expanded form. Write the following numbers in expanded form. A 5314.23. B 31506 base 8. C 232.01 base 5. Now, solution. A. This one without any base means it's already in base 10. So don't be scared if you see something like that. If they did not put any base there, it means it's already in base 10. So for you to expand it, the first thing is that before decimal point, just label the top. Put 0, followed by 1, 2, 3. Immediately after decimal point, put -1, followed by -2. So to expand that one, it will be equal to 5 times 10 raised to the power of 3 plus 3 times 10 raised to the power of 2 plus 1 times 10 raised to the power of 1 plus 4 times 10 raised to the power of 0 plus 2 times 10 raised to the power of -1 plus 3 times 10 raised to the power of -2. B. This one is in base 8. That means you are multiplying each digit by 8. So the next thing is that come here from the units, put 0. For tens, put 1. For hundreds, put 2. For thousands, put 3. For 10,000, put 4. So that means 3 times 8 raised to the power of 4 plus 1 times 8 raised to the power of 3 plus 5 times 8 raised to the power of 2 plus 0 times 8 raised to the power of 1 plus 6 times 8 raised to the power of 0. And you have to note that any number raised to the power of 0 is always 1. Now, for C. So before decimal point, so this 2 is units, so 0. This 3 is tens, put 1. This 2 is hundreds, put 2. So immediately after decimal point, it's supposed to have the power of -1. After that one, -2. So let's expand it. So, and the base is 5. That means we are multiplying its digits by 5. So this is 2 times 5 raised to the power of 2 plus 3 times 5 raised to the power of 1 plus 2 times 5 raised to the power of 0 plus 0 times 5 raised to the power of -1 plus 1 times 5 raised to the power of -2. So that is how to expand it, how to write it in expanded form. So here is exercise for you to do. So write it, you can write it in the comment section for me. I'll go through it. So write these numbers in expanded notation. 9008 without any base. I told you if you find any number without any base, you should know what it means by now. Now, B, 10111.01 base 2. 302014 base 5. 324001 base 6. So you have to expand them. So that is all about today's topic, number basis. So we continue from where we stopped because it has not finished. So till I see you in the next video, thank you and God bless you.